Good afternoon, all. I'm Sanjay Mavi, Senior Lecturer in the Department of Mechanical Engineering, IIMT College of Polytechnic, Greater Noida. Today I will discuss about the powder metallurgy. The content of today's lecture is the characterization of engineering powders. Next is production of metallic powders. Then conventional pressing and sintering. After that, alternative pressing and sintering techniques. And at last but not least, materials and products for PM. PM, that is powder metallurgy. So let us discuss these all the content one by one. First of all, what is powder metallurgy? Powder metallurgy is a manufacturing process in which materials or components or parts are made from metal powders. So powder metallurgy is a manufacturing process like other manufacturing processes. But in this manufacturing process, we convert the raw material, that is metal, into powder, then get the final product by powder metallurgy process. If we talk about the importance of powder metallurgy, or why do we need powder metallurgy, then the parts produced from or by powder metallurgy can be mass produced to net shape or near net shape or accurate shape. By doing this, we eliminate or reduce the need for subsequent machining. Clearly, if we produce the part or product almost accurate shape, then the other operations needed to bring that product into final shape will be eliminated. Then PM processes. Here PM stands for powder metallurgy, and I will use PM for powder metallurgy during this lecture. Then PM processes wastes very little material. Secondly, if we use PM processes or powder metallurgical processes, we can reduce the waste, and up to 97% of the powders can be converted into final product. PM parts can be made with a specified level of porosity. This is very important advantage of the powder metallurgical process. The PM parts can be made with a specific level of porosity to produce porous metal parts, such as filters, oil impregnated bearings, and gears. These all can be produced by powder metallurgical process only, not by other processes. Certain metals that are difficult to fabricate or manufacture by other methods can be easily manufactured by powder metallurgy. For example, the tungsten filaments which we use in bulbs are produced by powder metallurgy. Some alloys or combination of alloys and ceramides. Ceramides means materials produced from ceramics plus metals are called ceramides. These are made by powder metallurgy or PM. The PM production methods can be automated for economical production. If we introduce the automation in PM production, then it will be more economical. Now come to the powders. As powder metallurgy involves powders, so let us talk about powders. So here engineering powders. What is engineering powder? Powder can be defined as a finely divided particulate solid. The powders, these powders or these engineering powders include metals and ceramics. Now come to the geometrical features of the engineering powders. What will be the or what is the geometric features of the engineering powders? These are particle size. Particle size means the powder of the matter made up of particles. The particles have a certain size. This is the particle size. Next is particle shape. Particle shape is the shape of that particle of this is the powder. And the next is surface area of the particle. The particle shapes in powder metallurgy may be spherical. You can see here easily spherical, rounded shape particles, cylindrical shape particles, spongy shape particles, vesicular shape particles, flaky, cubic, aggregated. These are all the shapes of the particles of this powder or metallic powder is made up of. Now talk about the interparticle friction and powder flow. This is very important as long as we talk about the powder metallurgy. Interparticle friction. Interparticle friction is the friction between the particles of the powder. And it is very important because this powder is used to produce the final product. So friction between particles affect ability of a powder to flow readily and pack tightly. A common test of interparticle friction is the angle of repose formed by a pile of powder poured from a narrow funnel. You can see this test here. We have a funnel and we put the powder of the metal in this funnel and collect this powder here. The pile of the powder makes an angle. This angle is called the angle of repose. Larger angles or larger angles of repose means interparticle friction is greater. If the angle of repose or this angle is smaller, the interparticle friction will be smaller. Some observations which we have noted from interparticle friction are stated here. Smaller particle size, generally smaller particle size show greater friction and steeper angles. The angle of repose is greater, so the friction is greater. Spherical shapes, the particles or powders which have spherical shapes have the lowest interparticle friction. As the shape deviates from spherical to other shapes, round shapes, spongy shapes, vesicular shapes, as we have discussed just, then the friction between particles tends to increase. So the shape of the particle should be spherical. If we don't contain the shape into spherical, then the friction should be greater than expected. Easier flow particles correlates with lower interparticle friction. To reduce the interparticle friction, we add lubricants in the powder to reduce the interparticle friction. This facilitates flow during pressing. Now let us discuss about the production of metallic powders. If we talk about the metals, any metal can be made into powder form. Any metal can be converted into powder form. There are three principal methods by which metallic powders are produced. These methods are atomization, chemical method, electrolytic method. In addition to above these three methods, some mechanical methods are occasionally used to reduce powder sizes. Now let us discuss about atomization. How to convert the metal into powders. So atomization is very important method to convert the metal into powder form. In atomization method, one of the method is gas atomization method. In this method, high velocity gas stream flows through expansion nozzle, siphoning molten metal and spraying it into chamber. You can see it here in this diagram. We have a container in which we store the molten metal. Molten metal means melted metal. Then we put a expansion nozzle in this molten metal. Then a high velocity gas is flows through this expansion nozzle. By this, the molten metal keeps up flowing and converted into small particles, and these small particles collected into this chamber, and the powder of metal is collected here. You can see here in this figure easily. Next, atomization method is water atomization method. In this method, high velocity water streams flow through nozzles, rapidly cooling and solidifying molten metal into collection chamber. You can see it in this figure. The molten metal is collected in this container. This molten metal comes from this opening, and a high velocity water stream from this side and this side flows through these nozzles. This water cools the molten metal and converted it into small particles, and these small particles collected here. So water atomization method is also used to produce the powders from the metal. Now come to the pressing and sintering. Pressing and sintering are the parts of the powder metallurgy. The first part is the conversion of metal into powder, then pressing this powder to make it into desired shape and size, and after that we heat this compacted part below its melting point. So conventional powder metallurgical part making sequence consists of blending and mixing of powders. Blending and mixing of powders. The powder, the powder formed in previous process is blended and mixed during this process. After that, the process of compaction is bring. In compaction, we press the blended and mixed powder into desired shape, and this shape can be of any shape or size of which we want to produce a part. And after compaction, the sintering process comes into the place. In sintering process, heating in this sintering process, we heat the green compact produced from the compaction below melting point to cause solid state bonding of particles and strengthening of parts. In addition, about these secondary operations are sometimes performed to improve dimensional accuracy, increase density, and for other reasons. This is performed if we need it. The conventional powder metallurgical production sequence is given in this slide. As we have discussed, first is blending and mixing, second is compacting, and third is sintering. You can see blending process here. We put the powder in this container, then add some lubricants in this if we need. After that, we mix it into this container by rotating and spinning this. Then compacting. In compacting process, the blended powder is put into the cavity or die, and then we press this powder in this punch and die system. After that, we get this compacted part, and this compacted part is heated to get the desired final product. This is called sintering. The heating of the compacted part or green part is called sintering. Blending and mixing of powders. as I have discussed, blending is the process of mixing of the powders, but powders of the same chemistry, but possibly different particle size are intermingled in blending. Different particle size are often blended to reduce porosity. This is very important. If we want to reduce the porosity of the final product, then we should use the different size of the particles. In mixing, powders of different chemistries are combined. Now talk about the compaction or compacting. Compaction is the application of high pressure to the powders to form them into the required shape, as I have discussed earlier. The conventional compaction method is pressing, in which opposing punches squeeze the powders contained in a die. You can see it here. We put the powder in this die and press this powder with the help of punches. Work part after pressing is called a green compact. The part which is obtained from the compacting process is called green compact until or unless it is heated. So before the sintering process, it is called green compact. The strength of green compact of the part when pressed is okay for handling, but for less than after sintering. Here, we are talking about the strength of the green compact. The strength of green compact is lower than the sintered part. So, green compact must be sintered or heated to get high strength. This is the conventional pressing in powder metallurgy. In conventional pressing of powder metallurgy, actually this is the compact part of the compacting process. Here we put the metal powder in this die. Here is punch 1 or lower punch, and here is upper punch. After filling the die with the powder, we press both the punches and get the powder into the compact green. This is the compact green, the green compact. Now let us talk about the sintering. The heat treatment to bond the metallic particles, thereby increasing strength and hardness, is called sintering. As I have discussed earlier, sintering is the heating of the green compact to below its melting point. Usually in sintering process, we heat the green compact at 70 to 90% of the metal's melting point. That is below its melting point. Next is sintering sequence on a microscopic scale. Here we are discussing about the what changes occur during sintering process in the green compact. In figure 1, you can see particle bonding initiated at contact point. Here, this is point bonding. Next is contact points grow into NACs. As we heat the green compact, we get NACs formed here. You can see here. After that, pores between particles are reduced in size. After getting NACs, if we heat further the green compact, then we get pores between the particles reduced to this size. After that, if we also increase the temperature again, the grain boundaries develop between particles in place of neck regions. These are the grain boundaries. You can see here. This is the sintering sequence on a microscopic scale. Now talk about the alternative pressing and sintering techniques. Till now we have discussed about the conventional pressing and sintering techniques. Now these are some alternative pressing and sintering techniques. The conventional press and sinter sequence is the most widely used, as we have already known it. Now, some additional methods or alternative methods for producing powder metallurgical parts are isostatic pressing. In isostatic pressing, hydraulic pressure is applied from all directions to achieve the compaction. Powder injection molding, PIM, is also used as alternative pressing and sintering technique. In PIM, the starting polymers has 50 to 85% powder content. The total powder content of the metal has the 50 to 85% of the polymer. And this polymer is removed after the sintering process. Hot pressing is also an alternative pressing and sintering technique. In hot pressing, combined pressing and sintering means pressing and sintering both processes take simultaneously. That is called hot pressing. Means compacting and sintering both take place simultaneously. Now discuss about the limitations and disadvantages of the powder metallurgy. So if we talk about the limitations and disadvantages of powder metallurgy, the most disadvantage, or you can say limitation, is the high tooling and equipment cost. Means initial cost is very high. The tools and equipments required for the powder metallurgical manufacturing process is very high. So we can say it is a disadvantage of PIM. And the next is metallic powders are very expensive. That is Metal is converted into powder form to produce the part from powder metallurgy. This costs very dearly, so it is also a disadvantage. And next disadvantage is the problem of storing and handling metal powders. Means over the time period, the metallic parts can be metallic particles can be degraded. Fire hazards is also a possible case here. And if you talk limitation on the part geometry, because metal powders do not readily flow literally in the die during pressing. So the powders, as we have discussed already, interparticle friction. So interparticle friction plays a very big role in PM. It is also a limitation for our PM processes, and variations in density throughout part may be a problem. The variation of the product, variation in the density of the product may be take place because it is a real problem in powder metallurgy. Now discuss about the powder metallurgical products, the products which are produced from the powder metallurgy. These are gears, bearings, sprockets, fasteners, electrical contacts, cutting tools, and various other machinery parts. If we talk about the advantage of the PM with powder metallurgy, the parts made by powder metallurgy are very accurate to its required shape and size. When the parts produced in large quantities, such as gears and bearings, these parts are made from powder metallurgy, and the powder metallurgy is ideal process for these parts, bearings and bearings, if they are manufactured in large quantities. Thank you.